algorithms in a constraint model framework.
So what an honor to be here today, really. And ironically, I have just come from Hastings St. Leonard's, which is indeed the one of the childhood homes of Alan Turing. And I can't promise that this is in any way a contribution that equals his, but I hope you enjoy it anyway. So what I want to talk to you about is sensor utilization. It's actually sensor and effector utilization. Oh, there we go. And what it basically brings down, it's in the field, or the motivation for this is ISTAR. And that breaks down into ISR and target acquisition. And one part's really about sensing and understanding, the other part is about affecting. And what we want to be able to do is can make a consideration for using auction algorithms or pairing association algorithms to be able to consider available resources that might be there in terms of UAVs, what type of tasks that they currently are going on, the sensor types that they carry, and the environment in which they operate in. And what we're going to do is introduce a framework that sort of does something along this lines that we'll subject to EA, okay, evolutionary algorithms. So there's two sort of main approaches to this. One's the Hungarian algorithm, sometimes called Munkeris, and the other one's the auction algorithms. The Hungarian algorithms is basically a lowest fit, and basically it starts with an excess format. Effectively, you've got your tasks and your workers. What you do is you take the minimum value, subtract, and you've got the excess work that any one other pairing would have. And you look at the number of zero crossings that go with that. And if a number of zero crossings with the minimum number of lines to copy across, either horizontally or vertically, matches the number of associations you need, job done. If it doesn't, you have to go on to the second stage there and do it in the reverse, horizontal rather than vertical. And if that still doesn't work, then you go into an iterative approach, basically selecting other points, selecting the zero value for them. So what you're effectively doing is changing the search point. Okay, and you do that until you find an association. Okay, so that's actually quite a deterministic sort of single shot pairing association. And the other one is the auction algorithm. And the auction algorithm is fairly obvious, but there are quite a few forms of auction. The English one is the one we're kind of most used to, the gavel and call your bids. The Dutch auction works in reverse and basically starts from the highest value. As soon as somebody calls a bid, it's over, that's it, it's one. Scottish auction is similar to that, but what it does, is different from that. It uses time epochs, which allow time for consultation. Japanese auction is very similar to that. There's just nobody calling out, they leave the room. The candle auction is a bit of a weird one. It basically goes until the candle runs out. So that's basically like a kill dead switch on it. And the victory sounds a bit weird. The second highest price at the highest bidders win. Okay. Well, actually, that's like eBay. You know, when you put your max bid in, that's exactly what you're doing. Actually, Vickery actually won a Nobel Prize for this, because that work there actually is meant to encourage honest behaviours in economics, which you can imagine is in high demand. So what we want to do is get a bid strategy and some notion of getting a price and getting it lower than its value. And when we think about something like eBay, we can kind of sort of see that. We've got recommended retail prices, a guide price. We can look at the conditions and all those kind of things. As soon as we look at anything like land prospecting, suddenly this area becomes really complicated. Okay, and auctioning tasks down a kill chain is something that's quite hard. It has a lot of dynamics to it. Okay. So what we want to do is institute a constraint model. Constraint models, often known in project management, just help decisions to basically be able to aid the decision making. So maybe in defense, what we'll find is that quality never suffers, and time and cost might. We all know about programs overcutting, but none of them should go quality. When it comes to consultancy, it's kind of the opposite way around, or public transport. Quality is the first thing to suffer. Yeah, time and cost tend to be coupled and immovable. Okay, so that's kind of what we want as a constraint model for that. The constraint models that we're kind of looking through is something called mission threads. And here's a very famous one by General Ronald Fogelman, which is the find, fix, track, engage, assess. With reference to the last presentation, that was the steer I was saying towards having something that actually segments the intentions. There's another version of this by this really obscure person here, which I just brought out. And essentially what he was trying to do was the opposite thing, which was detect or make an assertion as to what an aggressor thought you were in your kill chain. Yeah. And so this would be really good if we could fuse the two things, because we can see there's no recognized step and there's no assess phase. So if we organize the things together and just for completeness add an identify step, then we get this F2 right head. And the reason why we want to conjunct these two together is if we're going to make a prediction about which part of the kill chain you are, it would be pretty good if it matched your own idea of your own kill chain, wouldn't it? So it has a chance of matching. So the paper also recommends this F2 right head kill chain. So to explain those sort of kill chain steps, we have the find and fix. Some sensors will give you a fix or give you range with it, give you altitude with it, some will not. So the find and fix is all about position identity. The recognize step is all about categorization in terms of knowing what it is, and different sensors again will give you an identity or not give you an identity. So this is a fusion in the start point. Then we've got the tracking gauge, which is about increasing our idea of prediction of where something will be in the future. And then we've got the prosecute effect, where we're doing something about it. And the assess is about making sure we don't have to do anything about it anymore. Okay. So if we take sensor types that we might have on all of our little UAVs that are kicking around, we have some radar things and we have some sort of ELNT things and some camera things, and they are good and bad at doing different things, okay, in the way I just spoke. So the radar things might be find and fix, because they had that all-important ranging we heard about, and the EO stuff might be really good at tracking and identifying, because you can visually identify, not so good at the discovery, yeah, because you've got to point them. Okay, so that gives us a sort of sensor record idea that we're having as we're going along this, where we've got positional records with some determinism or something we need to develop, and categorization of the records for recognize and identify that we need to do, and some kind of keep the hold on the kill chain step. Combined with this, we also have the environment of which those sensors are operating. Can be a challenge as well. Some of these things like to operate with shallow grazing angles, so hilly areas are not so good. Some of them might also be a little bit susceptible to fog and cloud, so there's an element of how that will map. And what we want to do is take all of this into account and have a mechanism for being able to make an optimal selection using an auction algorithm that is dynamic. Okay. So largely we see a trend in sensing platforms, which tend to be large jets at high altitude with low grazing angles, carrying such sensors, and smaller things that seem to be more about tracking and often carry weapons to complete that kill chain, that target acquisition element of them. I've got some examples there that come from the Elbit range there. So we have the Hermes 900 here, which you can see the weapon payloads in here, and sensors here as well. And we also have here the autonomous UAV Seagull, which obviously launches nice little deck guns and also torpedoes, depending on the role. This idea, by the way, of extending things to have different ideas and modular fits is something called role bandwidth, when you try and put them all on the same platform. And that's a trend we see. Anyway, so we largely see platforms that carrying these sensors also having some function towards this kill chain.
Hello?
So
Hello?
let's start at the beginning.
Hello?
What we want to do is kind of
Yes, you are.
create something which has a number of bias values, which is going to help us to be able to make an optimal selection.
No, thank
So
you.
in the recognize step, what we might want to do is declare something as time sensitive, high value, threat, or non-threat. Okay, and the highest value we'll want will always be time sensitive, right? Because we don't do anything about time sensitive target immediately. Well, if we've got something else in the way, well, by definition, we should have done something about it. Okay, and we also don't want any other task to interrupt it if it's already going. So from the time sensitive assess, it's a top priority, and they count backwards through the kill chain stage. Simple. Similarly, the threat value, the high threat is the next to count back, and then the threat value is the next. And then we get to a few little slightly more curious corner cases here, where we haven't quite got the fix in the identity, and or where we are wanting to track objects that we don't know. And if they're unknown, because they could turn out to be PST, they tend to be higher than the non-threats. Okay, so basically, when we're not doing anything, we're maintaining a situation awareness picture. When we've got something that's really good, we go to prosecute it down that kill chain and not interrupt it. Okay, so that's very good for one dimension, the kill chain. Next thing we need to do is add something to that in order to have a idea of how well those sensors do in those, to select the right sensor in those kill chains. So we can put some grading values in these. And I've just made these values up. We'll come back to point as a start condition, because what we'd want to do is optimize these with the EA algorithms under different operational conditions. And then also what we'd like to do is that connection to where the sensor operating in the kill chain state is, and the sensor where it is operating in the environment in which it's operating, have a score that builds into that. What we want is all that to build into a cost function to put into our auction algorithm, okay, given all those bias values. So we can collect the bias functions of the cost function like this. So what we have here is that just reverses the numbers. This is the number of values per the this value here, Bn here, is a number of values which is per those priorities to give it a spacing such that we can fit in an ambiguity sort of separating measure, which we'll talk about next, the environment and the sensor's ability to carry out the task, okay, added into that group. So what we end up with is CF becomes a function, that is the cost that will go into the algorithm, okay. So the last thing we have to do then is consider for sensor types how we distinguish between equally kill stage and equally up thing. And what we're going to do is calculate the maximum range that and then apply that to the time to get to that sensor, so that everything's very time-based here, as tasking tends to be. So what we essentially have got is a requirement for sensing. And in here, we can visualize this cost functions as a three-dimensional tensor, where one is the kill chain stage, one is the sensor type, and the other is the environment topology of which it's operating. Okay. Sorry, is it that better? Sorry. So that's great. And so one thing you might be noticing with this is there's actually an implied strategy being built. And what you might notice is that although we're always going for TSTs and high-value targets, that tends to indicate there's an aggressive strategy of attacking high-value targets and TSTs. But if we were being attacked, then maybe what we would want is we'd want a different strategy. So what we can do is we can layer with another mission thread for self-protection and have a different strategy. Okay, so we can break into one and then break back to the original task. Okay. And so that would allow us to have a different strategy for protection, etc., and have these mission thread layers. And the biases may be tailored for reasons of those strategies. And the idea about this is that we would be able to subject these these bias values that we have calculated to evolutionary algorithms to optimize them. So what in actual fact the bias values have done is made a flexible fabric for a state model, okay, of which we can adapt. So what we got there, so we've got a situation where we can take in the level of complexity, we've simplified it with these constraint models and these mission threads and the layers of them, and we can take into account different sensors, we can take into account the R2 right PED mission thread stages, we can take out the suitability of the sensor to carry out the task and the competition with other tasks, and also the environmental constraints of that sensor that is operating on that, all in one go. The notion of a game strategy is there, and it will be enhanced with EA and optimized with that. And we can also make an evaluation of the quiz platform to facilitate platform, anyway, basically to get the as the reward function for essentially getting a better optimized result, and it's extensible to other mission threads. Okay. And that's it. I do actually have a partial prototype. I was going to put a video, but I just wasn't confident in one, sending it, and two, it playing. And because it's a partial prototype, I prefer to show you the full prototype. So, okay, any questions?
Thank you very much. We have time for a couple of questions. Yes.
So since we're unfamiliar with everything, but it seems strange from an external perspective.